Hello everyone, we are from group number 6. I'm the group's leader, GKT Bandara, index number 216010P. Today we are looking forward to talking with you about X86 architecture. So let's get started. In this presentation, we will discuss about this content. So first I'm handing over to Gayuni for the introduction. Gayuni?
Thank you, Tarindi. I'm Gayuni Madanayaka and my index number is 216072F. I'm going to talk on the introduction of X86 architecture. The X86 architecture is instruction set architecture series for computer processors based on the Intel 8086 CPU. This was developed by the Intel Corporation in 1978. The architecture outlines how a processor responds to and carry out various instructions sent from the operating system and software applications. The architecture consists of 8 general purpose registers, 6 segment registers, 1 flag register, and an instruction point. Handling programmatic function is the main function of the architecture. Also provides services such as memory addressing, software and hardware interrupt handling, input-output management. Companies like Intel, Cyrix, AMD have adapted this design, but only few companies like Cyrix, AMD, Wire Technologies have the license of this. As of June 2022, most of the computers sold are based on this architecture. Here you can see the diagram of the architecture. The architecture is mainly divided into 2 independent functional units as bus interface unit and the execution unit. The function of the bus interface unit is to fetch instructions from the memory, also to send data to memory and input-output ports. The function of the execution unit is to tell bus interface unit where to fetch instructions from and where to send them, also to decode and execute instructions. Let me tell you about some features of this architecture. This architecture is an enhanced version of 8085 microprocessor, provides a conceptual framework for processors' instructions to be executed. Also provide techniques to manage and use the hardware components of the CPU. Its operating voltage is 5 volts and operating frequency is 5 megahertz. 16-bit of data can travel on the data bus at a time and the address bus can handle 20-bit at a time. Thank you. Next, I would like to call Upani to talk on her part. Over to you, Upani.
Thank you, Gayani. My name is PAUS Rupasinghe and my index number is 216113J. I'm here to talk about the history of x86 architecture. The companies such as IBM, Cyrix, AMD, Wire Technologies manufactured x86 processors intended for personal computers and embedded systems. In 1978, Intel introduced the 16-bit 8086 microprocessor. Early versions of these microprocessors were 16-bit, and later on they developed it to 32-bit microprocessors. In 1985, the Intel introduced the microprocessor 80836, which was later renamed as i386 microprocessor. And also following that, in 1989, they introduced the i486 microprocessor. i486 microprocessor had higher performance than the Intel i386. Also, it represents the 4th generation of binary compatible CPUs. Around 1993, Intel introduced the Pentium brand name for their new set of microprocessors. Because of this trademark, the other companies started to name their microprocessor designs according to a numbering scheme. The International Business Machines Corporations aligned with Cyrix Corporation designed 5x86, 6x86, and 6x86MX designs. Early versions of these microprocessors had problems with them. 6x86 microprocessor had minor compatibility problems and heat dissipation problems. Also, the K5 processor, which was the first microprocessor introduced by AMD, had reported having poor performance. There were many competitors such as Center Technologies, Transmitter Corporation, and VR Technologies, apart from the ones I mentioned before. The VR Technologies introduced the C3 and C7 processors, and originally it was designed by Center Technologies and later on sold by VR Technologies since it was introduced in 2005. Many additions have been made to the original set of x86 instruction set over the years, and although the x86 architecture has been implementing processors from Intel, Cyrix, AMD, only few of these companies have the architectural license, as Gaini mentioned before. So only Intel and AMD actively produce the modern 64-bit designs, which is also known as the duopoly of Intel and AMD in my x86 processors. So I hope you got an idea about the history of x86 architecture. So I would now like to invite Tharindi to talk about registers.
Thank you, Upani. I'm going to take the part of registers, which are the hardware components of 86-bit processing computer. Registers are the temporary storage locations that are directly accessible by the processor used to store data, instruction, or an address. Registers are very fast since they are very close to the processor. From the assembly programming language perspective, they are registers are like a set of variables with predefined names. Let us know more about the registers accordance with this architecture. In the case of Intel x86 architecture, there are two versions can be mainly focused. On 32-bit 86 systems, there are 8 general purpose registers and the instruction pointer. 32-bit registers are 32 bits wide. When they expanded it into 64-bit, they increases the number of general purpose registers to allow compilers to have more registers in which to manipulate values. AMD did their 64-bit extension in the Opteron and Intel Pentium 4. 64-bit is the extension version of the 32. And these are also, and there are also 128, 256, and 512-bit registers. So these are the general purpose registers that we have in x86 32. EAX, EBX, ECX, EDX, ESI, EDP, EBP, and ESP. EAX register is basically a 32-bit register. It is divided into two sub-registers, that is 16 bits each. The lower is called AX, which is raised from 0 to 15. This AX can further be divided into 2 of 8 bits each, which is AL ranges from 0 to 7 and AH from 8 to 15. Those are the lower and higher portions respectively. So the similar explanation goes for EBX, ECX, and EDX. EAX is an extended accumulated register. It just accumulates data. EBX is extended base register. It can be used as a pointer to memory addresses in RAM. ECX is an extended count register, which is usually used to store the count of any loops that we make. EDX is an extended data register. It's just somewhere to put some data while using other registers. So the next is ESP, EBP, and EIP. These are the pointer registers. With this stack structure in the x86 architecture, the direction of growth goes down. So the stack pointer in our architecture, we can access it through the register ESP, is the top of the stack. EBP is the reference pointing to the base of the stack. And EIP is used to track the address of the current instruction running inside the application. SI and DI are the source and destination index related to loops and arrays. They have conjunctions with DS and ES, which are the segment registers. Onto the segment registers, DS, ES, CS, and CS. Data segment register holds all of the instruction or data that we are not running. And extra segment register, it's just we can use for whatever we have to use it for. Stack segment register holds the stack segment the program uses, and the code segment is where the code is stored that we are actually running the instruction. So these are the basic registers and their functions in x86 architecture. The next part of our presentation is addressing modes and instructions which can be used in registers. So it will be covered by Chirani. Over to you, Chirani.
Thank you, Tarindi. My name is Chirani Disaka. My index number is 216091L. I'm going to talk about addressing modes and instructions. In the x86 processor, a program is limited to referencing an address space of size 1 MB, that is 2 to the power 20 bytes. Therefore, addresses are 20-bit long. A d-bit long address allows referencing 2 to the power d different things. As an example, 2-bit addresses which have 4 things 00, 01, 10, 11. In this case, these things are bytes. These are the formulas for 16-bit, 32-bit, and 64-bit x86 processors. Instruction relative addressing in 64-bit code is RIP plus displacement. RIP is the instruction pointer register, which simplifies the implementation of position-independent code. There are 3 types of machine instructions: data movement instructions, arithmetic and logic instructions, control flow instructions. Move, pop, start, load effective addresses are examples for data movement instructions. Addition, subtraction, increment, decrement, shift left, shift right are examples for arithmetic and logic instructions. Jump, control jump, return, subroutine call are examples for control flow instructions. That's all about addressing modes and instructions. So I would like to invite Dilmi to discuss about operating modes. Over to you, Dilmi.
Thank you, Shirani. I'm Dilmi Abeyawardena. My index number is 216003X. I am here to talk about operating modes of x86 architecture and difference between x86 and x64 architecture. x86 processor includes 3 main operational modes. They are protected mode, real address mode, and system management mode. Protected mode is the inherent state of the processor in which all instructions and features are available. Programs are given separate memory areas named segments, and the processor prevents programs from referencing memory outside their assigned segments. And the real address mode allows for the program environment of the processor to switch into other modes. Since the addresses in real mode always point to the actual places in memory, the mode earned its name as real address mode. As system management mode provides an operating system with a mechanism for implementing functions such as power management and system security. These functions are usually implemented by the computer manufacturers who customize the processor for a particular system setup. In addition to these 3, there is a protected mode version called Virtual 8086 submode. While in this mode, under the protected mode, the CPU is able to execute real address programs such as MS-DOS programs in a safe environment. In other words, if an MS-DOS program crashes or attempts to write data into the system memory area, it will not affect other programs running at the same time. So these are the operating modes of x86 architecture. And next, I would like to invite Kasundi to talk about x86 data types. Over to you, Kasundi.
Thank you, Dilni. I'm Kasanda Vermala. My index number is 216134A, and I would be explaining about Intel 86-bit data types. So as these words, 86-bit data types, explain themselves, 86-bit data types are the data types that are being used in microprocessors which are built upon 86-bit architecture. These data types transform codes into executable instructions that the processors can understand, and they decide what operating system and which applications should be executed. 86-bit processors can handle the data types that are of 8 bits, which we call as a byte, 16 bits, which we call as a word, 32 bits, double word, 64 bits, quad word, and 128 bits, double quad word. For the purpose of maximizing the flexibility in data structure and in order to use the memory space effectively, words do not need to be aligned at even-numbered addresses, and double words do not need to be aligned at addresses that can be divided by 4. But if the data are accessed over 32-bit bus, the transferring starts at addresses that can be divided by 4, and data transferring starts to take place in units of double word. These data types that are of 8 bits, 16 bits, 32 bits, 64 bits, and 128 bits, which we call as a byte, a word, double word, a quad word, and a double quad word respectively, are referred to as general data types. But furthermore, 86-bit processors support a wide variety of unique data types that can be recognized and operated on by specific instructions. Some examples for those data types are integer, ordinal, near pointer, far pointer, bit string, and byte string. As a part of the extensions of the instruction set to optimize the performance of multimedia applications, the packed SIMD data types, the packed single instruction multiple data types, were introduced to 86-bit architecture. The fundamental concept here is that numerous operands are put into one single referenced memory item, and these operands being processed simultaneously. These packed SIMD data types are packed byte and packed byte integer, packed word and packed word integer, packed double word and packed double word integer, packed quad word and packed quad word integer, and finally, packed single precision floating point and packed double precision floating point. So that's all for the Intel 86-bit data types. Now, Dilmi will be explaining about the differences between 64-bit architecture and 86-bit architecture. Over to you, Dilmi.
Thank you, Kasundi. So then let's talk about the difference between x64 architecture and x86 architecture. You already know x86 is an instruction set architecture family for computer processors, and x64 is also a family of instruction set architecture. x86 is emerged from Intel 8086 processor, and x64 came as an extension to x86. x86 is a 32-bit architecture, while x64 is a 64-bit architecture. x86 need to use more registers to split values and store them. In x64, values that can be stored are larger. And x86 can only parallel transmit 32 bits as it has a 32-bit bus. In x64, it can parallel transmit larger size data along the 64-bit data bus. So x86 is less powerful than x64, and x64 is much improved and powerful than x86. Then I would like to invite Diniti to talk about examples of x86 architecture. Over to you, Diniti.
Thank you, Devni. I'm Dinti Vijendra. My index number is 216153F, and I'm going to talk about the examples of x86 architecture and its pros and cons. This picture shows us the examples of 86 architecture. When we are talking about 86 processor range, 8086, 8088, 8286, 86 was the starting family of 8086 and 8088 microprocessors. This started with 16-bit and later improved up to 32-bit instruction set with 8-bit bus size. Maximum RAM is 1 MB with 10 to 20 MB storage space. The capable operating systems are DOS and DR-DOS. x86 processor range 8486. Mainly, this range of processors belong to 32-bit bus size with different clock speeds. For 86SX with 40 MHz and for 86DX with 100 MHz. The physical RAM can expand to 4 GB. The storage capacity is 200 to 500 MB. This is capable for operating systems such as Windows 98, Windows 95, DOS and DR-DOS. 86 processor range, Xeon and Core i9. This is the Intel's newest processor range. This range belongs to 64-based x86 family with a clock speed of 3.3 GHz to 4.3 GHz with a bus size of 64. Maximum usable RAM is 128 GB to 3 TB with 500 GB to 10 TB storage space. The capable operating systems are Windows 10, 11, 8, and Linux. So these are the examples of x86 architecture. This has a range of pros and cons. Pros of x86 architecture. First one is more expandability. x86 is a family of microprocessors. It can expand up to high processors like 8286, 8386, 8486 up to Core i series processors. Improved 86 has a more powerful performance. It allows you to perform several activities at the same time from a single instruction. The cons are, this generates more heat. Due to this, the performance of the device may decrease. System upgrades need to change the processor. For an example, upgrading an 8286 machine to a high-end machine means to replace the whole motherboard instead of replacing the processor. This is an extra cost for the user. x86-based application programs cannot run on improved version. Example, 64-bit application programs cannot run on x86 32-bit operating system. So these are the pros and cons for x86 architecture. As the conclusion of our presentation, we have identified that the x86 architecture is based on the Intel 8086 CPU and it operates programmatic functions and provides services which include memory addressing and software and hardware interrupt handling. x86 data types transforms codes into instructions and identified 5 sorts of data types. More expandability and more powerful performance are the advantages. At the same time, there are disadvantages as if the system needs to upgrade, it needs to change the processor and generate more heat. And that's all about our presentation. Thank you all.